Hi, I'm Bill Seaman. I'm going to be our moderator today for this AI talk. I'd like to thank B3, Jenny Mueller and Becca, and our technical people today, Handau and Urta. We have with us today, first I'll do a short introduction for myself and then we'll introduce the other people. I'm the Graduate Program Director of Computational Media, Arts and Culture at Duke, and I co-run a lab called the Emergence Lab. And I've been very interested in AI and what I call neosentience for almost 20 years now. We have Sophia Crespo and Anna Dimitriou, and hopefully Karim will join us. Sophia, would you mind introducing yourself?
Yeah, thank you. Hi, I'm Sophia Crespo. I'm a generative artist and I work with machine learning and neural networks. I have a main focus in nature and how we can use new technologies to connect with nature from the perspective of not using technology or seeing technology as a completely separate framework from nature, but rather kind of reconciling both of them. And yeah, thank you very much for having me here today.
And Anna Dimitriou, can you tell us about yourself?
Yeah, I'm Anna Dimitriou. I'm an artist based in Brighton, fascinated in AI, A-life and robots. I work a lot with robots, and I used to be the artist in residence in the Centre for Computational Neuroscience and Robotics at the University of Sussex for quite a few years, and now I'm the artist in residence at the University of Hertfordshire, initially in social robotics and now in the biocomputation research group.
Super. So I have a few different questions and we can let these move off in different directions. The first question is a kind of general one, which is, what are the ways we can help computers understand context? From my perspective, the kind of learning systems, computers have no idea about the kind of context that they're doing or creating. Sophia, would you like to speak about that first?
Yes, I think what constitutes context is what we define as relevant, and to a computer, only what we point out as legitimate sources of data, like input or valid representations of context, are in phase what the computer acknowledges as context. So I think it is really important for us to be transparent about what kind of context we are creating for the algorithms to learn from, because we are ultimately deciding that. Either we do that consciously or not consciously aiming to do that.
And Anna, do you have thoughts about context, computational context?
Yeah, I mean, I'm thinking there's a big connection here with this issue of attention in computation. So when you have the sensors, you have these sort of hierarchies of, in a robot, for instance, what does it pay attention to first? Like things like, you know, if we're like a human jumps at a loud bang and knows that something's happening, and you get this sort of issue. But with a robot, does it know to pay more attention to that, or to, you know, a quiet noise or something? It depends on how you set up those hierarchies in their kind of computation. And then so with context, that's all part of this, because a loud bang in a firework display is not a big issue, but a loud bang in a war zone, if you were using a robot in a combat, that's a very big issue. So I think this thing of attention and how the robot decides to pay attention first is very important. It's something we used in our cyberspecies proximity robot, which observes body language and then responds to people's body language, and also uses things like LiDAR and SLAM algorithms to move around spaces. But it's this sort of thing, is what does it pay attention to first, and what can it access through its sensors?
Yeah, part of my own research, this neosentience idea, is really thinking what's at operation in the human and trying to create a new kind of bio-algorithm. So I'm very interested in the idea of sort of giving the computer senses and having a kind of pattern flow language where they actually build up meaning very similarly to the way that we build up meaning using multimodal sensing. I'm along with that, I'm really thinking about transdisciplinary research, and I wonder if you can talk about how transdisciplinarity folds into what you're doing. Sophia, if you would go first.
Yeah, I think transdisciplinary research is super important to create like a critical conversation between different fields so that we can work together. I believe something that's super relevant to that is kind of the democratization of tools so that they can become available to people in different kind of levels of research as well, and different fields, and also to establish like a communication between fields too, because I think just some years ago everything that was AI tools was exclusively available to people who maybe had like a PhD in machine learning or were exclusively choosing to research that. But fortunately, nowadays, one doesn't need to specialize in computer science to be able to understand how AI technologies kind of work, even if one doesn't fully understand everything, like the algorithm to the very basic mathematical structure. But it's important to understand like how a bias can happen, right? So I think moving forward, it's also important to think not just how we can create transdisciplinary research next year, but in the long term. So like what will this research be like in 100 years and in the future?
Yeah, that's a very long period. That's interesting. Anna, do you have a thought about transdisciplinarity?
I mean, I think it's important to first kind of differentiate between sort of interdisciplinary and transdisciplinary in terms of what that means to people, because the way I understand it is interdisciplinary is obviously sharing between the disciplines, artists working with scientists and so on. But I think somebody might not be muted because I can hear feedback. Yeah, that's better. So in terms of, so you've got interdisciplinary, where you've got the knowledge sharing between different fields, and you've got, say, artists working alongside scientists, but the artists are using artistic methodologies and the scientists are using scientific methodologies. And I think of transdisciplinary, and I think it's kind of been defined as that, is more where the methodologies are also blurred. So the artists might be using scientific methodologies and the scientists might actually be using artistic methodologies. And I think having artists embedded deeply in these science settings is the really key point to that, to having like an art science transdisciplinary dialogue, because once the artist is deeply embedded, they can start really taking on some of the understanding of how to perform the science, how to think about the science side, and then you get this full blurring, you get this kind of hybrid objects that become art and science and AI research and all sorts of things from it.
Yeah, I fully agree with that. Yeah.
From some years ago, 2011, I worked with Otto Rossler, and we wrote a book called Neosentience, and it had hundreds of little chapters. And I discussed the idea of recombinant intellects, that if we took different of these perspectives and bridged them, that they would suggest new ideas. And from that, Roger Molina said, "Well, Bill, what's the next step?" He was with Leonardo at that time, and so I created a disciplinary search engine called the Insight Engine. And the idea of this was people could put many papers, or they could have videos, or they could 3D models, all different kinds of things in the database. And if you clicked on any two people, we used computational linguistic methodologies to map out the relationships between everything. And so you then do a bisociation. This is an idea from Arthur Koestler about how these two different things would bring in a set of text that may or may not be relevant to you. And we got this engine working. It was very exciting, but it was a closed system. And so now I'm in the process of making a new version of it that would enable the legal use of all of these papers. So people who could give the copy use would do that, or we would set up a link that would go to where they could access the paper, but we would still use the abstract as a way to do the kind of linguistic study. So I'm very excited. I hope both of you will contribute to that later on once that opens up. But part of what's so interesting is when you're really thinking about AI on the deepest level, no single person can solve this. So I'm thinking about how do we make a new kind of algorithm that sort of represents what's actually going on in our body. Can different people contribute to this, as well as what are the ethics of this, as well as how can we deal with computational creativity? This whole system is called the Insight Engine. So if we were, yeah.
Sorry, I just wanted to say something that for me personally, I think is really important, is that that's the reason why I think it's important to engage with the non-human or more than human and to see them as equal. Because if there were to be, like, if we're working on a neo-sentience or a new form of consciousness, it's really important to welcome it with from a perspective of empathy. So I just wanted to shortly just mention that.
Yeah, that's in fact the subtitle of our book was The Benevolence Engine. So we were really thinking about that and the importance of that versus the kind of military research that's going on. Do you have a perspective about that, Anna? I know we're going a little off the question that we started, but we have plenty of time.
What Sophia was saying immediately made me think of my other big interest, which is bacteria and the microbiome and the impact that the microbiome has on like the human body and things like that. I mean, in terms of like modeling life in a computational form or something, you kind of have to think about we're actually like a human, or even most organisms are kind of super organisms anyway, with thousands and thousands of different types of bacteria affecting things like levels of anxiety, what kind of food they choose to eat, all sorts of things. And so actually, this kind of idea of complexity, it's sort of increasingly complex the more we engage with what Sophia was saying, this sort of thing of treating all these organisms equally as equally important. Then we are these superorganisms, and so that really springs to mind there. And then that's a sort of transdisciplinary thing again, where you need microbiologists and lots of different kinds of microbiologists as well, bioinformaticians and all that, to kind of feed into something like that as well. Because I see sometimes computer scientists, when they're modeling bacteria behaviors, and they're actually really not that good. And I usually say, well, what about this and what about this? And it causes quite a lot of trouble usually in seminars and things when that happens. But it needs a very transdisciplinary perspective to kind of do those things. And I think that sort of thing with the idea of empathy and seeing others as other organisms and everything as kind of equally relevant in this context is very important.
Yeah, this idea of scales, even going down to the nano level. If you know Jim Zeski, who works with Victoria Vesna, an artist from UCLA, he's really doing some brilliant work along some of these lines. And so one of the ideas might be with this new bioalgorithm that it would be n-dimensional. Instead of being a kind of linear algorithm, it would have to be something that could deal with these levels of scale of different qualities somehow. So that's a very interesting idea. How do you write a new kind of computer code that has, in a way that our brain has distributed processes, but now you're talking about another whole layer of processes, which I haven't fully thought about code for something like that. Do you have a sense of how you might make a code, Anna, in relation?
I was just thinking that when you were talking, it made me think of Varela's concept of autopoiesis and this, system of processes that creates the sort of the cell wall, but can be kind of scaled up, and that Luhmann talked about in terms of the institution as well, this sort of system of processes that creates the system of processes, really. So that can be either a bacterium with a cell wall, or it could be the planet, or it could be the universe. It depends on, then again, we're into the context thing. But it is, there have been computer models of autopoietic systems. So it could be interesting to think about it in that sort of way.
Do you have a sense, Sophia, about a new kind of coding, or have you ever thought about that?
Yes, I was recently having a talk with somebody who does computational neuroscience, and they were saying, oh, we already struggle to compute one single neuron and everything that one single neuron can do. And we were talking about, like the millions and millions of neurons that a being can have, and also the other cells, not just the neurons, and how to model that computationally. And we were saying, okay, perhaps it's necessary to go one lower level and to think about the organelle, and then that like the organelles inside the cell and what they are doing. And then we ended up talking a bit about endosymbiosis and the idea that our cells as were originally a single organism, and the mitochondria, I think, was a bacteria, and they merged to create like a single cell, and the mitochondria allows for the synthesizing energy basically for the rest of the cell to power it. And so that kind of already, going back to what Anna was saying, that allows for a completely different view of how we are made, or what we are actually made of, and how that reading about this whole theory just made me think that I'm an emergence, but I'm made of several little lives happening, and I'm not just one. So yeah.
One of the things that I've gotten really interested in doing is looking back at history to a place called the Biological Computer Lab that Heinz von Forster was the head of. And a lot of these people, Maturana, Varela, Gordon Pass, many people were there. And there's a fantastic book called Unfinished Revolution in the Biological Computer Lab by Mueller and Mueller from Echo-ROM Press. And it's interesting that most computer scientists have never even heard that this particular lab existed. So that kind of work. And then there's also the quantum side, the kinds of work that Penrose and this OR, I think they deal with the organelles as part of that. And so it's super, super complex. So in a way, we can only sort of chip away at it, but I think it's somehow a paradoxical thing that as we do this research, it tells us more and more about what it is to be human, ironically. And then the idea of abstracting that into these kinds of systems. Do you?
I was just going to say, I felt the same thing when I started working with neural networks, that ironically, this was teaching me something about being human. This was showing me something about how what being human is like. And I thought there was an irony in that, that I'm learning through a computer algorithm.
Yeah, and so I think you mentioned, this very long kind of research goal, and unfortunately, science right now and funding tends to be like this 1-year model. And so I'm very interested, I guess as an artist, I can sort of break the rules and help create people, bring people together. I guess that would be my goal in this Insight Engine. One of the big problems is, how do we avoid bias? So how can we avoid bias and articulate concerns related to AI also as we do the study? So on the one hand, we're trying to do these. On the other hand, we want to make sure that we're not being biased, or we're not not creating, racial stereotypes and things like this in the systems. Yesterday, one of the people on the panel was talking about, when you come in airport and you're sort of using facial recognition or whatever, they're like giving you different lines to go into, and there's a kind of bias that's built into this vision system. So Anna, do you have thoughts about that? How thinking about bias?
It's interesting because you say you want to avoid bias, but I think actually what you're talking about is a kind of positive bias. Do you not think? Because it's very difficult to completely avoid bias, and if you did, I don't know what the result might come. That's the thing. A lot of these machine learning things are kind of sort of unbiased, and then they come up with these like horrible results that we don't want. So you've got this sort of problem that you kind of need a positive moral bias in them that, and that's complicated because we don't have across humanity, there isn't an agreed set of moral rules. We have sort of vague rules, and I guess you can put those in, but like the in-depth ones, that's very situation dependent, that's wealth dependent, and all sorts of things as to the kind of biases people have. So it's very difficult to remove bias completely. One of the good things about having artists in research setting and engineering settings is sometimes you can sort of just raise these issues. And although it doesn't deal with in the AI side, it deals with it or it can help deal with it in the context of how these systems are being built. So Alex May and I were artists in residence with Schindler, the huge Swiss engineering firm who are the second biggest producers of elevators in the world. And they produce they huge systems, but it's not just elevators, it's very complicated, like people movement systems and stuff like that. And they're very interested in very cutting edge futures of cities and what that will look like, and electric vehicles and self-driving vehicles and all sorts of things to move people around. And so we were working with them and looking at robot design and how we might think about robots. And we created this robot that kind of problematizes certain aspects of this stuff. And one thing was we were looking at what color should a robot be? Because actually they've got like the majority of robots are white. If you make a robot black, it looks people seem to perceive it as an evil robot. People have done these tests on this shooter bias, you know, that whether you save the pedestrian and shoot the gangster or whatever, that shooter bias occurs if it's a robot, it still occurs the same thing. So people are more likely to shoot a black robot than a white robot. So these ideas of like, what color do you make a robot? Do you make a yellow robot? What does that say? If you make the robot red, that also looks kind of evil. So we made the robot grey. I'm not saying that's a design solution, but it's a kind of, it makes explicit that there's this issue. And also the idea of robots from the initial sort of beginning of the word, this, robot means worker or forced labour, robota in Czech, I think. So you've got all kind of things inherent in robotics research from the beginning, that you are kind of making these workers for us. So we're playing with all those kind of contexts in it and getting the researchers to kind of think about these things, because also, you know, in Switzerland, it's a rarefied environment. So they're although they do work everywhere around the world and they're very deeply engaged with these kind of issues, it's still interesting to kind of raise them in that kind of environments. And that was funded by EU funding with the STARTS program. So that was really interesting to have that experience. We wouldn't have experienced working with a company like that, I don't think, otherwise.
And Sophia, do you have thoughts about these issues of bias? And
Yeah, I agree with Anna about the positive bias. I think it's super important to take it from a perspective, or a humble perspective, of we're always going to have a bias no matter what we do, because pure objectivity isn't really attainable. But I think it's important, well, transparency is extremely important there, to invest in being critical and being open to rethink how we are doing things. And also, I think it's super important to not establish like that AI is a fully black box that is doing its own thing, and that we can't, as humans, have agency towards what goes in it, what it's going to learn from, and what kind of values we want it to learn. Part of the issue with the AI hype, in my opinion, is that it teaches people that AI is something that as humans we cannot understand. I mean, I've had people tell me, oh, you're an AI artist, so you don't do any art because the AI does everything for you. Where's your art? And this was a random conversation in a plane with somebody I didn't know, but I thought, interesting. I never thought of it that way, because it learns purely from what I choose, and even if I want to work with nature, and even if I want to create a perspective of a humble approach to nature, I still have a bias of what an aesthetically pleasing organism looks like to my work, right? So I'm still creating a bias there. So yeah, I think it's all about yeah.
Yeah, I mean, some of the things that I think about is that as we move to what Ray Kurzweil calls the singularity, when we have robots that are, autonomous and so on, which I think may happen in our lifetime. So many things are happening very quickly. The fact that they're learning systems and so on, going back to what Anna was saying about these robots that are, basically coming from the Czech, basically worker robots. It seems to me that there may be a total cultural shift where robots want to have autonomy and also take on a kind of learning of aesthetics of their own. So there may be a whole kind of neo-sentient aesthetics that will come out of the relationship of human aesthetics to aesthetics that might be important to robotics. And do you have so in terms of this cultural shift, one really wonders what that will mean. I'm not sure at all, or if there's going to be different varieties of AIs. Do either of you have thoughts about that area? I mean, Anna, what's your thought about this notion of the singularity, or do you think that's a kind of mythology?
I think it might be a mythology. Some people have suggested, well, we're in it, and it's an ongoing process, which I quite like the idea. If we have to sort of think about it, because I'm not sure that there'll be this moment when it just sort of flips and a robot says, "Hey, don't switch me off." That's that sort of running joke that you can program in the computer lab. You can program the computer to go, "Don't switch me off. I've gained sentience," and people don't do. But I was thinking about you were talking about the robot aesthetics. We did a project. It was working with a scientist who was working with this human brain project, and they're working on artificial noses. And we were thinking about artificial, like a computer, a robot that could smell things. But the kind of sensors that are available at the moment are kind of looking for chemicals. So we made this like robot perfume, which would be attractive to robot nose. And so the idea is you can squirt it on yourself, and then the robot will kind of be attracted to you. And we were thinking about the context when because people talk about robot companions and things like that. Robots, maybe you want to be attractive to robots, and maybe you can wear robot attracting perfumes. It doesn't smell very nice to humans, but it's sort of smells a bit chemically, but it certainly attracts robots.
Interesting. And Sophia, do you have ideas about this kind of neo-sentient aesthetics or robotic aesthetics that would be different than human aesthetics?
Okay, so I didn't go fully into that yet. Like, like robot aesthetic, because I don't work with robots. But I can say that at least it's making us rethink a lot of things. I think we're learning together with the technology and with the, when we look at the technologies and how they are, how we think of a configuration, how we think of an interface, basically, by having to design these interfaces, we are learning about how we think, what is important to us that we need to interact with. So partly that. Then I also think, like, going back to what we were saying before about bias, I was thinking about how some time ago, where like the conflict aspect of a bias, there was this data set called ImageNet that had learned the category bad person. And, like everybody has kind of a different representation of what a bad person is. But as soon as we have to teach an algorithm to classify that, and, we make that data set open, we see, whoa, there's a problem here, because how can you tell from an image what a bad person is, right? Because it's something so abstract. So I think we're learning a lot through these technologies, and that's why I personally think it's important to not see them as separate from us, and I also agree that there's not going to be one single moment where we are going to reach the singularity and that's going to be it. It's going to happen. Maybe it doesn't happen, in a linear way, but the technology is working itself towards that. Maybe it never happens. Who knows? Because our understandings of the words are changing too, and the way we thought of artificial intelligence like 30 years ago or even just 20 years ago was completely different. And what a computer was also, like the word computer was completely redefined with the change in the technology.
Yes, I've thought a lot about that and about the Turing test and so on, and how these benchmarks. One of the things that Otto Rossler and I articulated about neosentience was that there would be a series of kind of pragmatic benchmarks that the robot would seek to take on. And so one is using natural language, another is being creative to some degree, building up knowledge about context with multimodal sensing, being able to think about acting in space before acting in space, the idea of mirror competence, which is certain animals, have this sense of self and others. When they see themselves in a mirror, they can kind of understand that. And then also this idea of benevolence as an overarching kind of goal. And again, those are like very, very difficult things to achieve. And then ultimately, the roboticist, and his name is escaping me, he has the subsumption architecture ideas at MIT. But he kind of imagines that through brain direct computer interface, that we're going to just slowly intermingle with the robot. So it's not going to be a kind of singularity that's separate from us. It's going to be this kind of hybrid species, possibly. Do either of you have thoughts about this kind of notion of the hybrid species? Anna, maybe first.
Yeah, I was thinking, I mean, we're talking about the kind of the history of computation and things, but actually, and I think what happens at each point is that the technology moves on, and a lot of the thinking, a lot of the ideas. I mean, you can go back to Turing, and he came up with a lot of this stuff. It's just that he didn't have the tools to do it, and it's the same in the field of microbiology that I work a lot with. Is that the tools are becoming more and more amazing, and we have a lot more access to being able to kind of study this stuff. And actually going into microbiology as well, we have this whole field now of synthetic biology. So we can kind of build to an extent, or we're on the verge of being able to build cells. And this opens up another aspect in computation, that we're talking about digital computers, but maybe we need to be thinking of actual biocomputers that actually use biological parts within them. And that might be something, because I mean, there's already been lots of work with robots being driven by sort of electrical arrays with neurons on and stuff like that back in the past. But actually something much more complex computationally. So actual biocomputing that's using rather than studying the studying biology computationally, it will mean also using biology in its building as building blocks. And I think that's going to be like the fusion. It's this kind of, really, it's a revolution that's happening very much at the moment, very current, and I think that's going to be the next revolution, is this fusion of these areas, and where that will lead. I mean, I can't really be sure at the moment, but it's going to be interesting.
Well, it's very interesting if you look back at von Neumann, who was at MIT, and also, one of these people very central to the computer and computer architectures and so on. At a certain moment, there were these incredible analog computers, and Vannevar Bush. I don't know if it's really worth searching it, because there are like these whole rooms of analog computers. And then what von Neumann said is, they decided to go with the binary because they wanted to cut out the noise. But I think the noise is what makes us human. Analog can have this kind of infiniteness, which is very different than the binary. Do you have thoughts about this also, Sophia? I'm sorry, I jumped in before giving you a chance to.
No, yeah, what you're mentioning about the noise is very interesting in the context of quantum computation and how it's being developed right now, because there's the issue of the amount of noise that the quantum computers have at the moment, and how we can measure, how we can distinguish signal from noise. But aside from that, I wanted to say that I think, so recently I was watching this documentary about the brains of birds, and at the very end, the scientists were saying that they were studying this research, which was very controversial in biology, because it was about the empathy of crows, the capacity for them to feel empathy towards each other. And when they said that it was very controversial, I thought, interesting, because I would never think that, I mean, why would that be controversial? If we can feel empathy towards each other, why wouldn't another living being feel that, why should we think that they aren't able to feel that? So yeah, I think that as we make this progress, it doesn't just happen within technology, but it happens as well within the biological sciences too, that we open ourselves to the idea that all these life forms can also feel and express in their own way things that are very similar to us, and that empathy can manifest itself in all this diversity of ways, that isn't just like the anthropomorphic kind of model. So yeah, that's kind of what I think about it.
We're very close to the end now. I think we have about 30 seconds each. Is there one final last thing you'd like to mention in just a short burst? It's been a very interesting discussion, and I appreciate you both very much. Anna,
thank
do you have
very
a final?
much.
Thank you.
So,
yeah. I think the only thing I was thinking is to do with what you were saying about the past research and the cutting out of the noise. That's something that happened in microbiology as well, where people like Pasteur and Robert Koch would separate out the infectious agents, and in the past people only studied the things that made us ill. And now these tools have moved on and the technologies have moved on. Now we're looking at this idea of the microbiome and all this complexity because we can. And I think that's what's going to happen with AI in the future. I don't think we're going to go through an AI winter. I think we're going to start getting into some of the more exciting questions that have been with us forever in AI and are still with us. And we need to work on them some more with the new tools that we have.
And Sophia, any last pointer or observation?
I cannot think of anything else to add right now. I'm just thinking about this. It's been a very interesting conversation. So yeah.
Yeah, and I also got very interested in the idea of making electrochemical computers. So I've even written papers in thinking of approaches of how you might do this. So I guess we're at the end now, and I thank you, B3, for having us. And maybe if there's a last thing to talk about, how, in terms of books and papers and so on, what do you imagine in terms of how we're doing this research? How do we come to know these things? That's Insight Engine for me is a very exciting platform to enable people. But do either of you have platforms or websites that you particularly use in terms of AI, or a favorite place from getting papers and things like this? Okay, I guess we have to wrap it up. They typed warp.
I can say I learned a lot from ML4A, Machine Learning for Artists.
Okay.
That was kind of one of the open source, sources of knowledge for me online. But yeah.
Okay, nice. Anna, in a burst.
I'm a big fan of Twitter. I follow lots and lots of my favorite scientists and people on Twitter. And they all post all their latest papers on there, and they post all the latest interesting research. So I use that. I think as a really quick way of keeping up to date with all the latest stuff.
Okay, well, thank you so much for participating today, and I hope our audience enjoyed it as much as I did. It was very interesting. Okay, bye-bye.
Bye-bye.